Hi, we are Team 5 for CPSC 545 Software Architecture, and we are going to talk about the introduction of IEEE 147 and ADD 2.0. My name is Ashwin and I am joined with the following teammates as shown in the slide. This slide covers the agenda for today's presentation. So let's talk about IEEE 1471. The IEEE Computer Society has developed the standard for the architectural description of the software-intensive system. The IEEE 147 applies to the architectural description to determine the scope of what architecture should cover, and it describes various views to the customer, sales and the marketing team to get the support and funding, and it can be implemented to achieve the real value. This shows the importance of the architecture, which helps the system to be developed faster, cheaper and better. Let's talk about the IEEE goals. First is to understand the architecture that is applicable to the software-intensive system. Second one is to build a framework in order to address the architectural issues of the system. Third one is to follow the architectural practices while building the software. And fourth one is to allow the new technology to follow those practices.
I'm going to talk about creating an architectural description. Here are the steps we are taking for initial activities, that is identifying the architectural description and including the version of the product. Then we are going to talk about identifying stakeholders and assigning their roles of an architecture. The third step consists of selecting a viewpoints and specifying the viewpoints. The fifth step consists of specifying the views. And the sixth one consists of record known as inconsistencies among the views and its fixes. The seventh one consists of create a rationale for the architecture. This slide represents architectural description. It is similar to the entity diagram in a database. Here we see how stakeholder architecture has an influence on a system. Architectural description has many viewpoints and it is confirmed by views which participates by model. This slide talks about purpose of an architectural description. Here it talks about the quality, performance of the system and capability to meet the needs and the concern of the stakeholder. And third one consists of understandability, consistency, completeness of the description.
Hi, I'm Praveen and I'll be covering architectural description practices and IEEE summary. Architectural description practices basically shows the elements which is included in the standard architectural description. The first one is the architectural documentation. It shows the information that should be present in the architectural document. Second one is identifying the stakeholders, where we find out different stakeholders related to the projects. The third one is selection of architectural viewpoints. Here we identify the viewpoint names and concerns of different stakeholders. Fourth one is architectural views. This section tells there should be at least one architectural view and each view should correspond to exactly one viewpoint. The fifth one is consistency among architectural views. Architectural design should record known inconsistency and should contain analysis of consistency across all the views. And the final one is architectural rationale. It describes the rationale for pre-existing legacy systems. The second slide talks about IEEE summary. Here we have the architectural description is a tangible set of products that comprises the architectural models and information necessary to understand the models. The IEEE 1471 recommended practices may be excessive if followed completely, but it provides a practical set of guidelines that can help the architect to focus on the important goals of producing an architectural description.
Hi, this is Akshita. Let's now discuss about the ADD concepts. What is a software architecture and what is an ADD? ADD is an approach to define a software architecture in which the design process is based on the quality attribute requirements the software must fulfill. Today's ADD outline is Introduction to ADD, ADD input-output and ADD steps. As we have already defined what is an ADD, let's move further. ADD follows recursive process that decomposes a system or system element by applying architectural tactics and patterns that which satisfies its driving quality attributes. The inputs to the ADD are mainly the requirements. There are three kinds of requirements: functional requirements, design constraints, and the quality attributes. Functional requirements defines a function of a system and its components, how the system should behave, and some constraints on the system behavior. Some examples of the systems are business rules and administration strategies. Let's now see what our second requirement, which is a design constraints. Design constraints on the system design will be applied till the end of the final design is completed. It contains some predefined decisions which provides us the satisfactory outcomes. Few examples of the system built must be accessible through the World Wide Web and include Oracle 8.0 for storage. The third requirement is the quality attributes. Quality attributes are basically non-functional requirements which evaluate the performance of a system. Quality attribute requirements such as performance, security, reliability, etc. Architects need to understand their design in terms of the quality attributes. Few examples of the quality attributes are achieving the deadlines in the real-time systems, how systems will respond in the event of a failure. These are the inputs to the ADD. The outputs to the ADD are responsibility, properties, and the relationship among the software elements, which provides us the proper whole bunch of system elements.
Hi, this is Marianne, and I'll be talking about ADD steps 1 through 4. Step 1 simply confirms that there is sufficient requirement information. Therefore, in step 1, it is important to return any non-prioritized requirements back to the stakeholders for ranking. Step 1 is also about making sure that there is enough information about the quality attribute requirements to help make the choice of elements. Each quality attribute should be expressed in a stimulus response form. In that form, each requirement will be described as a response to a specific stimulus, emphasizing the following. In step 1, no design decision will take place. In step 2, the ADD architect will choose an element of the system to decompose. Since ADD is a recursive architecture method, there is 2 ways that will lead you to step 2. If this is the first iteration to step 2, then a decomposition of the entire system elements is required. On the other hand, if this is not the first iteration, then only one element is selected for decomposition. An element is chosen for decomposition based on the business criteria, organizational criteria, risk and difficulty of the element, and the current knowledge of the architecture. Step 2 also requires no design decision. Step 3 involves selecting 5 or 6 high priority requirements as the candidate architectural drivers. In order to do so, a second ranking of the requirements is done according to their impact on the architecture. For instance, for an initial ranking of high, medium, and low, the second grouping will look like this on the slide. A ranking of HH is high in priority for both the stakeholders and the impact on the architecture. This ranking results in the selection of the candidate architectural drivers. However, the ranking could be changed as further analysis of the system takes place. Step 4 involves choosing an architectural concept that will satisfy the candidate drivers. In order to do so, the following 6 steps must be implemented. In step 4, major design decisions take place, including the functionality of elements, the relationship of elements to one another, and how the elements communicate with one another. The type of communication between the elements with external entities and the data models for the communication need to be determined as well. Also, it's wise at this point to think about the resources necessary for the software elements and how those resources will be managed. Some other things that need to be looked at is scheduling, abstractions, and quality attributes.
Hi, I am Karthike. I will be talking about step 5 and step 6. In step 5, architectural elements are instantiated and responsibilities are allowed to these elements. These instances are known as child. Responsibilities are allocated to child according to their type, as that of parent element. Additional instance can be added to it. Analyzing and documenting can be done on the basis of module view, component connector view, and allocation view. Several design decisions need to be taken during step 5. In step 6, elements interface is given to design process, like what services and properties are required. Interface example includes interface to system, interface between high-level system, and partitions between application within high-level system partitions.
Hello, I'm Divya Bhanushali. So let's continue with step 7. In step 7, we verify that element decomposition meets functional requirements, quality attribute requirements, and design constraints. And we see how these requirements and constraints also constrain other instantiated elements. After that, architect starts another iteration to decompose the child elements. One important thing to note here is that during the 7th step, no decisions about designs are made. After finishing step 7, we have to decompose the parent element into child element. So now each child element has a collection of responsibilities. And then in step 8, we start from step 2 where we have to select another element to decompose.
My name is Ashwin and I will cover the comparison between the IEEE 147 and ADD 2.0. Basically, IEEE allows you to study the different architecture which is followed in an industry, and ADD focus only on the architectural views. IEEE 1471 allows the transition from the legacy architecture to the new architecture, but ADD doesn't allow any inheriting architecture. IEEE 147 is a non-recursive approach, whereas ADD is a recursive approach. IEEE 147 allows you to add new requirements and features in the ongoing process, whereas the ADD doesn't allow you to add new features in the middle of the life cycle. This slide covers the references for today's presentation. Thank you.